The notes today deal with story problems specifically that have inequalities. So we're going to be given a story problem. We will need to write and then solve an inequality that should answer the story problem. Probably the biggest issue that I see students have with story problems dealing with inequalities is learning to know which inequality we should use. Sometimes we'll have a greater than, sometimes a less than, sometimes greater than or equal to, sometimes less than or equal to. We'll talk through a lot of the reasonings here as we go through the problems, but it would also be helpful to know if we are given either the phrase at least or no less than, we are going to have a greater than or equal to symbol. So at least means that whatever we're trying to find needs to be bigger than, or it could be equal to whatever the number is. Or if it says like no less than 50, whatever we're looking for needs to be greater than or could be equal to 50. In the same way, if it says at most or no more than, we will have a less than or equal to symbol. Sometimes it may say more than or greater than or less than. If it's more than, it can't be equal to, so it's just greater than. If it says less than, pretty clearly we would have a less than symbol. So I would either memorize this chart here, or we can reason our way through it, which is what we'll do as we work through our story problems. So example one, as always with story problems, you don't just want to have answers in your notes with no problems. So I would write the problem down. You don't have to write down every word though. The fact that her name's Debbie, not terribly important. At most $60 to spend, I would write at least that down. She wants to buy one pair of jeans for $22. And then she's going to buy some t-shirts. Each t-shirt costs $8. In part A, we need to write an inequality that shows the maximum number of t-shirts she can buy. So Debbie has at most $60 to spend on clothes. She wants to buy one pair of jeans for $22 and spend the rest of her money on t-shirts. Each t-shirt costs $8. Again, we are asked to write an inequality that, when solved, shows the maximum number of t-shirts that she can buy. And then we will solve the inequality and find the maximum number of shirts that she can purchase. So part A, we are trying to write an inequality that shows the maximum number of t-shirts that she can buy. I always, instead of starting out with all the variables and putting all the numbers in, is just start out with kind of a written inequality, a word inequality that we can then transform into an algebraic inequality. So she looks like she's spending money. So we are going to write down money spent. And we want to compare that to $60. So the money spent and 60, you should then think about which of these things needs to be more. Well, money spent cannot be more than 60. It has to be smaller than 60. So the 60 needs to be bigger, or they could be equal to each other. So that's where I would start. Money spent needs to be less than or equal to 60. Notice if you go back to the previous slide, at most, the phrase at most has the less than or equal to symbol. Now we need to change money spent into an algebraic expression. So we need to think about things that she spends money on. Well, she's going to buy one pair of jeans. That's going to cost her $22. So on jeans, she's spending $22. Plus, she's also spending money on t-shirts. She's spending $8 on each t-shirt. Well, we're not just going to put 8 here because 8 would imply that she's just going to spend that $8 one time. She needs to spend $8 on each t-shirt. So because she's spending that $8 over and over again on the number of t-shirts she buys, we're going to put 8x. 22 plus 8x is less than or equal to 60. That is the answer to part A when it asks us to write an inequality that we can then solve to show the maximum number of t-shirts that she can buy. It then tells us to solve your inequality. We've been solving inequalities once it's set up. I think we're pretty good at solving it. Subtract 22. Problems like this are usually calculator problems. 60 minus 22 gives us 38. And divide both sides by 8. $38 divided by 8 gives us 4.75. X is less than or equal to 4.75. There's the solve your inequality part. We did that. And then it also asks us to find the maximum number of t-shirts that she can purchase. Well, she can't buy 4.75 t-shirts. She can only buy a whole number of t-shirts. So she could buy 4 or she could buy 5. Notice it says X is less than or equal to 4.75. So 5 is not less than or equal to 4.75. The most number of t-shirts she can buy is 4. If she bought 5 t-shirts, she would have purchased too many. She would have spent more than $60. So I realize usually when we get 4.75 and it tells us to round to the nearest whole number is 5. But we want to use it in context of this inequality. We need number of t-shirts to be less than or equal to 4.75. The biggest number that's less than or equal to 4.75. The biggest integer that's less than or equal to 4.75 is 4. Example 2 says Keith has $500 in a savings account at the beginning of the summer. He wants to have at least $200 in the account by the end of the summer. Summer break is 11 weeks. We are trying to find the most amount of money that he can withdraw each week. And it says he can only withdraw whole numbers, whole dollars. Keith has $500 in a savings account at the beginning of the summer. He's not putting any money in his savings account. That's not a great idea, but he's only withdrawing money. It says he wants at least $200 in the account by the end of the summer. His summer break is 11 weeks long. What's the most amount of money he can take out every week? Again, we are going to start with words here. It looks like we're dealing with the amount of money in the account. And at the end of the summer, we need that to be at least $200. So we're going to compare that to 200. I want you to think about which side needs to be bigger. We want his money in the account to be at least $200. We want the money in the account to be more than, or it could be equal to 200. And then we want to think about what types of things affect the money in his account. Well, he starts with 500. He starts with $500 in the account. And then he's going to take out money. So we want to subtract the amount of money that he has. He's going to take out money 11 times. He's taking money out every week for 11 weeks. But we don't know how much money he's going to take out every time. So he's going to take out the same amount 11 times. We don't know what that amount is. So 11 times the amount that he takes out needs to be greater than or equal to 200. So he starts with 500. He takes out money 11 times, but we don't know how much he takes out each time. And again, the amount that's left in his account needs to be greater than or equal to 200. Now we need to solve for x. We start by subtracting 500 from both sides. We get negative 11x is greater than or equal to negative 300. We divide both sides by negative 11. Negative 300 divided by negative 11 gives us 27.27. When we divide by a negative, we need to flip our inequality around. So x has to be less than or equal to 27.27. It does say that he can only withdraw whole dollars, so the 0.27 we can't withdraw. So we need to think about, should we have 27 or should we have 28? It says x has to be smaller than 27.27. So something smaller than 27.27, the most amount he can take it out every week is $27. Example 3 says yellow cab taxi charges a flat rate of $1.65 for a taxi ride, plus 55 cents per mile that the customer rides. Katie has no more than $15 to spend on her taxi ride. Write and solve an inequality to find the maximum number of whole number miles that Katie can ride. So again, we're not doing a fraction of a mile. So it is $1.65 for a taxi ride plus 55 cents per mile. Katie has no more than $15 to spend. Again, I'm going to start with words, and then we're going to transfer that into an algebraic expression. Cost of a taxi, we want to compare that to the $15 that she has. We need to think about which of these needs to be more. Well, her taxi cost can't be more than 15, so 15 has to be bigger, or she could spend all $15. Now we want to think about things that are going to affect the taxi cost. Well, there's a flat rate of $1.65. So just to get in the taxi, it's going to cost her $1.65. She only pays that once. Plus, she has to pay 55 cents per mile. So she's paying that 55 cents each time she goes a mile. So each time, we're going to call the number of miles m. It needs to be less than or equal to 15. Solve for m. Subtract 1.65. I get 0.55 m is less than or equal to 13.35. Divide both sides by 0.55. 24.27. It says she needs to write a whole number of miles. So the number of miles that she rides needs to be smaller than or equal to 24.27. 25 is not less than that, but 24 is. 24 is the most number of miles that she can ride. And our last one, I want you to try this one. As always, pause the video, you try it, and then once you think you have it, you can start it up. So we are looking at the amount of money that Jeremiah earns. So I'm going to put money earned. And he wants to earn at least $5,000. And the amount of money that he earns, he wants it to be bigger than or equal to 5,000. Things that affect the amount of money he earns a base salary of $650 this month. Plus, he's also getting $350 for every car he sells. So $350 for each car. So the $650, he just gets paid that once. The $350, he gets paid it over and over again, depending on the number of cars that he sells. Subtract 650 from both sides. I get 350C is greater than or equal to, what is that, 4350. Divide both sides by 350. And we get number of cars that he needs to sell needs to be greater than or equal to 12.43. Again, we're not rounding to the nearest whole number. We are writing our answer as a whole number, but it's not necessarily the nearest one. He can't sell 12.43 cars. Number of cars needs to be greater than or equal to 12.43. 13 cars.